Welcome back, friends. We are now moving into session 8, which is focused on multiplication facts and looking specifically at multiplying by 4. So we're going to jump right in today and leap over to our document camera just for a quick second. Remembering that we have at this point now looked at our times 2, our times 10, our times 5, times 1, times 0 facts. If we were working through this with kids, those would be our first 5 foundational facts, and that we're using what we know about those facts to help us understand and really conceptualize the rest of these. So in the last session, we worked through our multiplication by 3, and we thought of that as doubling in one more group. And now as we move into multiplying by 4s, we're going to think of that as doubling and doubling again, as well as we can use some of our other strategies there. So let's hop over to our presentation here and let's go ahead and roll on through here. So if 3s, like we said, we're doubling in one more set, well, it makes sense then to do 4s next, because that would be doubling and then doubling again. So that brings us to our big picture piece, and we remember that with each set of facts that a student owns and they really understand, the number of remaining facts begins to decrease quite rapidly at this point. So we've now gone down to, once we know our 4s, we will have gone down to only needing 16 more unique facts. So for kids, this becomes a lot more manageable. I think it's good for kids to keep these charts for themselves, which are the facts they own, and it's okay. They may have an individual fact in there they still just struggle with, 6 times 4 or some fact, and they can certainly list that in a different color on their chart. So what are our big ideas for multiplying by 4? Well, we've already hit on the main one a couple times, right? That multiplying by 4 is really doubling a double. So if I can figure out what double something is, so if I'm doing 6 times 4, well, if I know 6 times 2 is 12, well, I can double that 12, and that'll give me 24. So 6 times 4 then must be 24. We want to continue to emphasize with kids throughout our study that patterning is key in mathematics, and that we can do a lot of predicting once we understand the patterns that are going on here. One of the major patterns we'll look at is that some of the characteristics that hold true for multiplying by 2 are going to hold true for multiplying by 4 as well, such as that they're always even numbers, and why is that true, and making sure that kids understand that. We always come back to the commutative property as well, because that limits the number of new facts that I have to remember as a student, right? So whether I picture it as 4 times 5 or 4 groups of 5 or 5 groups of 4, and we know those are two different things, however, they give us the same quantity whenever we go to solve that. And we want to help kids realize that, look, the progress you're making begins to really pick up steam at this point, because you already know all these other facts, and you can use those to help you understand these new facts. Some of the questions we might want to have if as a class or as a group that's working on their multiplication by 4s, looking at what does it mean to have twice as much, what does doubling mean, how would you double a double, why does that even make sense here, how does the order affect things, are all the multiples of 4 multiples of 2, and are all the multiples of 2 the multiples of 4? Hopefully they can realize the difference between those two as you'd work through a study of these with kids. And then, are they always even? So our text for this one is an interesting one. This text is used in mathematics all the way up through our higher level math. There's a lot of interesting connections you can make in this. So the book is If You Hopped Like a Frog, and some of the lead-ins for our kids might be things like, have you ever wished you were a certain animal? Have you ever wished you were an eagle or a bird or another type of bird? Have you ever wished that you were some other animal? These can be used later in the mathematics, as well as just getting kids to hook in with the text. So we'd want kids to chart out the type of animal they'd like to be, maybe look at some of the characteristics of those animals. And the point being that we're really trying, with all these literature links, to give kids something they can reach back into, something that makes more schema connections for them. So when they are struggling with a 4 fact, maybe they have something they can reach back into their mind and grab onto. We know that we've talked about each time making sure that you read the literature just for the literature's sake at least once. But as you're reading, we're asking kids to think about the number of legs for these different animals as you read. So we're going to be looking at this and tracking it on a line plot. So we're going to create a line plot with the numbers 0 through 8 for the number of legs, and we're going to complete that line plot as each animal comes up. So I won't do that for us here in the video, but that would be as a class, that'd be what we'd want to do. So remembering that a line plot ideally is going to look like a number line, and so you can see one here. So we know there aren't going to be too many animals with a one leg, right? So we're going to anticipate that most of our animals are going to have 2 and 4 and 6, and then if we had any spiders, we might have some 8s in there too. Again, something that's comfortable for kids, looking at animals, right? They know that chickens have a certain number of legs and cows have a different number of legs. So we're going to explore at the end, like which animals are going to have the fewest legs, which are going to have the most legs, and in the story and then in other places. So let's go ahead and jump into our reading of the text. So let me switch back over to our document camera and slide our book over here for us. So this is If You Hopped Like a Frog, and this is written by David Schwartz. And so if you already know this text, you can certainly jump ahead a little bit. And there's an interesting intro into the story that is, if you are going to create the what animal would you like to be with your kids, you might want to read, I would definitely encourage you to read the intro that David Schwartz provides here. And he says, when I was your age, most of my friends wanted to be astronauts or athletes or actors. And he says, I too dreamed of traveling in space, hitting home runs and starring in movies. But there was something else I wanted to do, and I never told anybody. I wanted to hop like a frog. I imagined soaring through the air with grace and ease, landing gently on my big springy legs. And I wondered, how far could I hop? I also wanted to eat like a snake. A snake could open its jaws wide, so it could swallow prey wider than its own head. I knew that it would be very bad table manners to eat things bigger than my head, but still, I wondered what it would be like if I could swallow and if I swallowed like a snake. When I realized that answering these questions took just a little bit of math, I had great fun astonishing my friends and my family. Once you know that a frog can jump 20 times its body length, you can figure out how far you would hop if you hopped like a frog. When you realize that a snake swallows food twice as wide as its head, you can find out what you could eat if you snacked like a snake. In fact, there's no limit to what you can figure out. It's simply a matter of math. So hop to it. So, if you hopped like a frog, you could jump from home plate to first base in one mighty leap. If you were as strong as an ant, you could lift a car. If you had the brain of a brachiosaurus, your brain would be smaller than a pea. If you swallowed like a snake, you could gulp a hot dog thicker than a telephone pole. If you ate like a shrew, you could devour over 700 hamburgers in a day. If you high jumped like a flea, you could land on Lady Liberty's torch. If you flicked your tongue like a chameleon, you could whip the food off your plate without using your hands. But what would your mother say? If you craned your neck like a crane, you'd have to stretch your arm way up to scratch your head. If you had eagle eyes, you could spot a running rabbit high in the clouds, from high in the clouds. If you dined like a pelican, you could slurp a triple root beer float in one mouthful. If you grew as fast in your first 9 months as you did in the 9 months before you were born, you would have been a towering tot, taller than a mountaintop, and heavier than 2.5 million elephants. If you scurried like a spider, you could charge down an entire football field in just 2 seconds. If you hugged like a bear, wait a minute, you already do. So if you want the actual math behind all these, the nice thing that David Schwartz does is that he provides you the context at the end. So I won't read through all those, but the if you hop like a frog is there, and it tells you what the connection is between your height and the length that a frog can drink, or can jump, sorry, and all those other pieces. So each of these are often used, especially in higher level math courses, to give kids a context for creating function charts and those kind of things. So let's think about that in terms of where we are. And again, we're trying to build this context for multiplying by 4. And so we're asking kids as we went through, what number of legs did the animals have? So they would have created this chart. And so the number of legs that most animals had was 4, and we could go back through and get those. And we could compare that. We'd like to compare that then to the number of legs that we have, which is obviously 2. So if we think about that, we could ask our group of kids, like, well, how many legs would 6 people have? And how many legs would 6 frogs have? Well, 6 people are going to have 12 legs, but 6 frogs are going to have 24 legs. Well, you can anticipate that we're getting into the multiplication facts here. So we're going to have them draw it out. We're going to have them predict it out for this situation and to write their multiplication sentence, which would obviously be 6 times 2 is 12, and 6 times 4 is 24. We want kids to do that not because we're telling them the fact, but because they've drawn it out and they've solved it, right? So let's go ahead as a class and let's make a list of all the 4-legged animals that we saw in our story here: the frog, the brachiosaurus, the shrew, the chameleon, and the bear. And how the kids choose one of those animals and use the recording sheet that we'll look at here in just a second. They're going to pick a number card from a 2 to 10 deck and put that number of people on the line on the sheet. And then they're going to draw a diagram and write the multiplication equation. And then they'll repeat that with another card from the deck. So the sheet simply looks like this. So you can see if I drew a 3, I would jot my 3 on the number line here to the left on the chart. And let's see, I'm not getting my pen, sorry, there we go. There we go. So I could draw my 3 over here on my chart, pick a color that you'll be able to see. So I could put my 3 in there, right? And so I've picked an animal. And so let's say my animal was the shrew, right? So how many human legs? Well, if this is a person, right, they're going to have 2 legs on this person and 2 legs on this person. Mine won't be as detailed as kids would write. And then how many animal legs would that be? Well, the shrew doesn't have 2 legs. They have 4 legs, right? So the shrew, that one's going to have 4. This one's going to have 4. And my third shrew is going to have 4 legs. And my pictures are not nearly as beautiful as the kids will be. And my multiplication equation here would obviously be, well, 3 animals with 2 legs each would be 6 legs. And 3 animals with 4 legs each, or 3 groups of 4, is going to be, well, I could count those up if I wasn't sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's going to be 12. And again, they would repeat the process, pull another card, and let's say they get 7, and they could do that here. Then we're going to share out as a class and talk about, okay, so what did your diagrams look like? What did your neighbors look like? Let's go ahead and chart those out. And what do we start to notice about times 2 facts and times 4 facts? So we're going to go ahead and create our times 2 and our times 4 chart and start to say, well, what do we notice about the data? How are the 2's and the 4's related? How might knowing what 2's look like help me find what my 4's look like? So again, using that same chart, I'm going to keep coming back to this chart, but then we're also going to create a class chart that might look something like this in terms of exploring the number of legs. So if I have 1 person, well, that's going to be 2 legs. If I have 1 brachiosaurus, that's going to be 4 legs. And we're asking kids then to make the connections and make sense of them. And they may need to borrow from each other what the pattern is there. As we look at giving kids more experiences with the facts, so let's talk about a 1 to 40 chart. So you see there are 3 1 to 40 charts here on this one sheet. So we're going to have kids create a multiple of 2 chart and a multiples of 4 chart. They're going to circle their 2's and X out their 4's. So to us that might be relatively quick and easy, but to students, especially if the 4's are relatively new to them, This could take a little while. You could certainly do the 2s on one, the 4s on another, and then combine them on the third chart. If kids are ready for it, they could definitely do it on one, and you could get 3 copies out of this one sheet. But the key questions we're exploring here are the multiples of 4 also the multiples of 2? And so they are hopefully going to realize that, well, every other multiple of 2 is a multiple of 4, but not every multiple of 2 is a multiple of 4. However, every multiple of 4 is a multiple of 2, right? So there's those nuances that start to happen that, oh, okay, so if I don't know, if I'm not sure if 6 is a multiple of 4, well, let's see, 2, 4, well, 4 is a multiple of 6, so the next one that would be a multiple of 2, but not a multiple of 6. There's all that discussion that has to happen between kids. It's easy for us. We have to remember we have thousands of experiences with these to quickly answer these questions, but kids don't have all those experiences, so it takes time. Another way to help narrow in the focus for our kids is to use the shaded multiplication table. I think we use this with our 3s as well. So if they have a shaded multiplication table, they're only filling in the 2s and the 4s. And again, this is just another representation of the chart that we used earlier in terms of number of human legs, number of animal legs. They're going to fill those in, and we're going to look for the patterns, right? We're going to ask them for what did they notice, and hopefully they notice that 2's facts are kind of like counting like 2's, and 4's facts are every other even number, and they're going to come up with their own things that they realize in the numbers. And it's important to get those student thoughts posted and accessible, because the way I as a student might remember it is going to be different than the way that another student is going to remember theirs. Again, the intent of the shaded multiplication chart is that it takes a little bit of the overwhelming nature away for the kids. Animals, again, are a comfortable thing for kids to use. If you have little plastic animals, and these are certainly easily accessible both online as well as if you want the actual objects. It's nice for struggling kids to have the actual objects in front of them. So if you gather plastic animal objects, and ideally just ones that have 4 legs, because if we're just focusing on our times 4 facts, grabbing 10 of those examples and creating the one, well, if I have 1 of these, how many legs do I have? If I have 2, how many legs do I have? We want to keep making the connection not just to the verbal version of the multiplication sentence, but also the written form as well. Other real-world connections, you have to remember a lot of things around us, not just animals, but most vehicles are going to have 4 wheels, most tables are going to have 4 legs. So we can use those to create our multiplication sentences. So if I have 1 table, that's easy. I have 4 legs. Well, what if I have 5 tables? What if I have 8 wagons? What if I have 6 mice? How many feet do I have? We definitely want to allow kids to create their own drawings. In fact, we want to encourage them, especially at first, to make drawings. And using those illustrations to create my number sentences, again, is making more and more schema connections for me. Once they have all those experiences, then we start getting into the abstract. And again, just even looking at the pictures, you can see the difference between a representational piece and an abstract, right? The numbers, although to us, the numbers are probably more comfortable, to our kids, they need that concrete piece, the representational piece, and then the abstract piece. Some kids are going to do that faster than others, but they all need that process. So we know individual checkups are important. Those individual student conferences, especially for struggling kids, are very important, helping them focus in on the facts they need the most practice on. And then using a fact progress chart. So here we've got, this is the practice or the multiplication for our multiplication facts. Having kids keep track of their facts. So if this group of kids is all working on their 4s, then we're going to do this over time. So we want to see how many did I get right on the first time, the second time. And again, you don't do this every day. Fact practice is good. It's good to have fact practice every day, but utilizing the games and those things, checking in on my progress is something that I want to do periodically, maybe twice a week is plenty there. So how do I build that automaticity? So kids aren't just going to get it because I give them more and more fact practices, but they need activities. So here's another idea. Again, any of these are in Word form. You can download if you have a copy of the text, if that's what you choose to get. So you could change these just as easily to make it fact fish times any of the values that we're working through. So kids are going to get 12 cards. To create a set in fact fish, we're going to create, we need both of the multiples as well as the product. or both of the factors as well as the product, sorry. They're going to, once they get all three, they can lay theirs down, and the player that gets the most sets wins, or you can play something like the player to make 3 sets wins. Another activity would be to create what they call in text crisscross facts. So 5 times 4, we're going to use something like coffee stirrers or tongue depressors. You can certainly use base 10 blocks if you wanted to. Whatever you're going to use to create nice crisscross pattern here. So they're going to use one of the values to create the rows and the other to create a column. And again, we're not looking at the spaces, we're looking at the intersections here. So how many intersections are there with 5 times 4? Well, I can count those up and I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. They cross in 20 places. So 5 times 4, there are 20 intersections there, and I'm going to write that out. I'm going to write the multiplication equation. I'm going to write the solution as well. Multi-models is another one you can use with any math fact very simply. So they're going to get a blank grid sheet like this, and they're going to pull out a times 4 card, and they have the area model here. Oops. They have the area model. They'll label the fact, so they're going to make, if I pulled out 4 times 3 as my fact, then I have to decide, am I going to do it, which way am I going to do that? So I'm going to put in 4 times 3 here. I'm going to label this. This one is 4 times 3. I can be a little strategic because I'm going to try to cover the most facts on my board that I can. So if I had 4 times, let's see, what do I have here? 1, 2, 3, 4, 5, 6. Let's call this, I think that's 7. Let's see, I did 4 times 7. I could lay it out here, right? I could put 4 times 7. So again, I'm doing these based on the fact cards that I pull, and eventually I want to cover as much of this chart as I can. Lots and lots of good, rich practice there, and drilling in that representational piece that these multiplication facts actually do live in a certain place. Not wanting to forget some of the activities that we've done with other facts. So fact card jumps, fact card arrays, fact sorting, triangle fact cards. These are all easy to, or not easy, but they're also activities that kids can do for practicing their forest facts. As we get towards the end here, we always like to come back and say, let's connect this to division. As kids become more comfortable with the multiplication fact, we want to make sure they remember that I can solve my division facts this way too. Looking at the animal example, so instead of knowing the number of animals and the number of legs, well, let's start with the number of legs, right? So if I see 24 legs, well, how many dogs would that be? You could also say if I see 24 legs, how many chickens would that be in practices 2's facts? 36 legs, how many turtles? 32 legs, how many polar bears? So these are great for kids to write too. They're great for kids to illustrate. They can certainly create division books for themselves too. Giving kids counters are certainly important. I apologize for the mistake on the fro instead of 4. By giving kids that support as they make the leap from multiplication to division, again, we've had so many repetitions with it, it becomes relatively easy for us. But we can give kids the chance using models to solve these division problems and to draw them out. Spin and cover is another example that we can use here. So players are going to try to cover all the quotients on their game board. Oops. The twist here is that the opponent gets to write the quotients on their opponent's game board. So I can put the same one up to 3 times on your board if I want to make it more difficult for you. So as I would spin this, if I got 28 divided by 4, then I could take that and say, well, 28 divided by 4 is 7, so I get to cover up the 7 if it's on my board, and I'm trying to cover up my whole board. So our goal here is that this is professional development that is adding to your toolkit and also giving you a chance to think through how do we teach multiplication facts. If you have certain multiplication resources that you use, please share those, especially as they relate to multiplying by 4. We're going to move into our times 6 facts with our next video, and your assignment for the 3 facts that go together here, times 3, times 4, and times 6, will come after the times 6. So once you've watched this video, you can just simply post in our assignment that you've watched it. And again, any of the resources you have, please share those as well. And we look forward to seeing you with our next session.